Good afternoon, everyone. I, on behalf of Institutions Innovation Council, Tripura University, would like to welcome you all to the talk on touchless hand sanitizing system. Today, we have with us as speaker Mr. Harjeet Nath, Assistant Professor from Department of Chemical and Polymer Engineering, Tripura University. I welcome you, sir. Over to you.
Thank you. Thank you, Mandakini, for your kind introduction. I welcome all of the participants in this particular session. This is a part of our Institution Innovation Council activity of Tripura University. I'd like to thank Dr. Shaun Roy Chaudhary for giving me the opportunity to present this talk today. She is the coordinator of this particular IIC Council of Tripura University. So as it is clear in front of you that today's session will be discussing on this touchless hand sanitizing system. So let us move on. I'd like to give you a small view of uh, what has led to develop all this touchless hand sanitizing system. I'd like all of
In
you to go
December
through this
2019,
particular video.
there was a cluster of pneumonia cases in the city of Wuhan in China. Some of the early cases had reported visiting or working in a seafood and live animal market in Wuhan. Investigations found that the disease was caused by a newly discovered coronavirus. The disease was subsequently named COVID-19. COVID-19 spread within China and to the rest of the world. On 30 January 2020, the World Health Organization declared the outbreak a public health emergency of international concern. In this video, we'll take a quick look at what is currently known about COVID-19. Keep in mind that this is a new disease, and what's known is rapidly evolving and might change in the future. So what is a coronavirus? Coronaviruses are a large group of viruses. They consist of a core of genetic material surrounded by a lipid envelope with protein spikes. This gives it the appearance of a crown. Crown in Latin is called corona, and that's how these viruses get their name. There are different types of coronaviruses that cause illness in animals and humans. In humans, coronaviruses can cause respiratory infections ranging from the common cold to more severe diseases. These include the severe acute respiratory syndrome coronavirus, first identified in China in 2003, the Middle East respiratory syndrome coronavirus that was first identified in Saudi Arabia in 2012, and SARS-CoV-2, the name of the virus that causes COVID-19 that was first reported in December 2019. So, where did this new virus come from? It's known that coronaviruses circulate in a range of animals. Sometimes these viruses can make the jump from animals to humans. This is called a spillover and could be due to a range of factors, such as mutations in the virus or increased contact between humans and animals. For example, MERS-CoV is known to be transmitted from camels, and SARS-CoV from civet cats. The animal reservoir of the new coronavirus is not known yet. How does the disease spread? The disease can spread from person to person through droplets, when an infected person releases those droplets through coughing, talking, or sneezing, for example, when close to another person. It can also spread when infected droplets land on objects, and when another person touches them and then touches their eyes, nose, or mouth. What are the symptoms? The incubation period, which is the time taken from exposure to the virus and development of symptoms, is on average 5 to 6 days, but can range from 1 to 14 days. There can be a range of symptoms, from very mild to severe. Some people may not develop symptoms. Common symptoms include fever, fatigue, and respiratory symptoms such as cough, sore throat, and shortness of breath. Some people reported loss of their sense of taste or smell, and some may develop a skin rash. In more severe cases, there could be pneumonia, organ failure, and sometimes death. About 80% of cases recover from the disease without needing special treatment. But there are some people who are at risk of serious illness. They include older people or people with underlying medical problems, such as chronic respiratory disease, obesity, diabetes, high blood pressure, heart disease, or cancer. How can we tell whether someone is infected? The infection is commonly diagnosed by a test called reverse transcriptase polymerase chain reaction, generally known as PCR. This test identifies the virus based on its genetic fingerprint. There's also a blood test that can check for antibodies against the virus, which may show that someone was infected in the past. How is it treated? The treatment for COVID-19 is mainly supportive care. Medicines against the virus are currently under investigation. How do we prevent transmission of the virus? There are a number of effective ways to prevent the spread of the disease. These include covering your mouth and nose when coughing or sneezing with a flexed elbow or tissue, and throwing the tissue in a closed bin immediately after use. Wash hands regularly with soap and water or an alcohol-based hand rub, maintaining at least 1 meter distance from people, and the appropriate use of masks and personal protective equipment, especially in health settings. It's important to stay home if you're feeling unwell and to call a hotline or your medical professional. But if you have a fever, cough, or difficulty breathing, seek medical care early and share your travel history or contact with someone unwell with your healthcare provider. In some areas, governments have implemented specific physical and social distancing measures to prevent the spread of the outbreak. It's important to follow their advice. Vaccines to prevent COVID-19 are currently under development, and scientists around the world are working hard to make this happen. That's a quick look at this emerging infectious disease. We're still learning about this virus every day, and what's known may change. So please, check the website below for the most up-to-date information. In December 2019,
Okay. So as you could see from the video itself, like what is the reason for this coronavirus pandemic and how it is transmitted and how it can be tackled to a large extent by using hand sanitizers as well as frequent hand washing and maintaining social distance. Now this particular session will be going through how to prepare some of the touchless hand sanitizing system, and my main intention would be to give you an oversight of how this hand sanitizing system actually works, what are the various types of this hand sanitizing system, and how this hand sanitizing system could be prepared by you yourself in your home in a very lucid and in a very elaborative way. I would like to start this particular session. So as you could see in front of you that this touchless hand sanitization system could be either with sensor or it can be without sensors also. For example, you would have seen in the market also, you would have seen in various places that there is something which is said to be the foot operated hand wash, where if you are using this particular pedal based soap dispensing column, where if you are just pressing this particular pedal, what happens is that there is one shaft in the top of the particular system, and when you are pressing this particular pedal, this shaft comes down and accordingly your soap gets dispensed in your hand. Now once the soap is dispensed in your hand, you straight away come to the foot operated hand wash system, where using the foot again you are able to switch on and off the tap and you could clean your hands. So these are basically soap based hand wash systems. But in the market also, you're nowadays seeing quite frequently there are something said to be the touchless hand sanitizing dispensing system, which uses a couple of sensors for dispensing the hand sanitizer to your hand. So let us now go and look and try to have some idea about how this kind of hand sanitizing system works. I know that most of the people over here are not from straight away technical background, so I just try to go in brief with each and every topic. I'll not go into the depth of each and every topic, but I would like to show you how this things particular works and how you can plug and play these devices, and straight away you can prepare such as touchless hand sanitizing dispensers in your home, and you can keep yourself healthy. So moving on. Now, if you would like to know about what are the two touchless sensors which are currently used in most of the hand sanitizing systems, then these two sensors are primarily the IR based sensors, which is said to be the infrared sensor, and the second one is said to be the ultrasonic sensor. Now the IR sensor looks like this, where you basically have two diodes. One is said to be the IR transmitter and the other one is said to be the IR receiver. Now, before understanding this transmitter and receiver, let me just give you a small idea about what is meant by this infrared. Now, we all know that light can be divided into various ranges. The spectrum can be divided into infrared, can be divided into visible, ultraviolet, and so on. Generally, all the colors which we could see using our eyes lies in the visible range, which is in between 400 to 700 nanometers. That means that when the wavelength of that particular light falls in between 400 to 700 nanometers, that is said to be the visible light, and we could see the color of that. Now, when you have the wavelength of the light above the 700 nanometers, then that is said to be the infrared range. So in this infrared range, though it is a light, it is a form of light, but still we are unable to view because of certain limitations in our eyesight. And when this particular wavelength is below 400 nanometers, this is said to be in the ultraviolet region. Now, this particular sensor works in this infrared region. That means this particular IR transmitter, it is nothing but an LED system where it releases an infrared light using this particular transmitter. And when this particular light goes and gets attracted, or it gets reflected from any body or any object, it reflects back, and that reflection, if it is received by the receiver, then that triggers some kind of an action in the circuit, which will lead to either activation of your hand sanitizing system or deactivation of the hand sanitizing system, vice versa. So that depends on whether this receiver is receiving the IR light or not. So this is one type of sensor, which is said to be the infrared sensor. We'll go in depth of this particular sensor in our subsequent slides. Then there is another type of sensor, which is said to be an ultrasonic sensor. Now, this ultrasonic sensor is also works on the similar phenomena where you have one transmitter and you have one receiver. The transmitter emits ultrasonic sound from its this transmitting region, and when it goes and gets reflected, when you have any object in front of it, it gets reflected from the object, and that reflection, if it is received by the receiver of this particular sensor, then that again also triggers some kind of an action in the circuit, which will lead to your sanitizer being dispensed. Now, this ultrasonic sensor, as I have said, that this is also a kind of a sound which is not audible by human ear because of certain limitations. We all know that our human hearing range is between 20 hertz and 20 kilohertz, but this ultrasonic range is above this 20 kilohertz range, in and around 1 megahertz range, and that's why it is not audible to our ears. So though this sound is being emitted by this particular ultrasonic sensor, but still we couldn't actually hear it, but still it is working. Now, as I've said, that when it goes and if there is any obstacle in front of it, the sound waves gets reflected from that particular object, and if it is being received by this transmitter, that triggers some kind of an action. Let us go into depth of it. I would be concentrating my talk more into this IR sensor today and less of this ultrasonic sensor, because here you need a lot of other descriptions to deal with. More technical things are there, but this IR sensor is pretty easy to prepare. Anybody could prepare with some basic knowledge. So that is the intention of today's talk, and accordingly we will be moving. So this is clear that mainly two types of sensors are there available, or which is being used to prepare such sanitizing systems. One is the IR based sensors and the other is the ultrasonic sensor. Now, when you say these IR sensors can also be divided into two types depending on its working. One is, if you use this IR sensor with a device which is said to be Arduino based devices, which needs coding, and it can be also connected and circuited in your hand sanitizing system without the need of any Arduino. That means without the need of any coding. Though there are various advantages and disadvantages in each of them. The most common example being in the Arduino based system, it is more technical. It is more controllable. You can control a lot of parameters. You could also measure a lot of parameters, but without Arduino based, you are not able to actually measure a lot of parameters. But for devising your hand sanitizing system, this is also one of the easiest method. But if you want to go more technical, if you want to measure what is at what distance your hand is there and at what distance you want to activate your entire thing, then you should go with the Arduino based devices. Now these Arduino based devices, you can also make use of your IR sensor, you can also make use of your ultrasonic sensor for your hand sanitizing needs. But when you come to this without Arduino based thing, here you can only make use of the IR based sensors, because this ultrasonic based sensors, it needs a lot of other parameters, which is actually easy if you use some kind of which is said to be the Arduino based devices. Now let me give you a small hint about what do you mean by this Arduino. Okay, now these Arduinos are nothing but they are a group of microprocessors and microcontrollers which are which are connected in a form of a circuit, and which will give you or which is equipped with a set of digital and analog input output pins, and it could be interfaced very easily with the help of USB based devices. And if you are coding any of this particular thing, which can be an either C or C++ based programming language, or it can also you can also use a standard API which is known as the Arduino language, and with that particular coding you can straight away put that coding into the Arduino using the USB based connectivity devices, and accordingly this particular sensor will be working. Similarly, for this ultrasonic sensor also, you will need to code it appropriately, and that code could be sent to this particular Arduino board, and then the system will be working appropriately. So these are two different kinds of Arduino, though their functions are pretty same, but this is somewhat cheaply available in market, and this is pretty costly, but you can use both of them for making such devices. Now today, as I've said, that I will be discussing more into how to prepare this hand sanitizing system using or without using the Arduino boards. Would be going into depth of how to connect these devices, or how to make such devices very easily in your home. Now it is clear that you can use either Arduino or without Arduino, and we'll be concentrating more into the without Arduino based things. If you are looking at this particular video over here, you could see that you could see one hand sanitizing system is there, which is again without Arduino based thing. And if you are just putting your hand in front of the IR sensor, then when your hand is there, the waves gets reflected back from your hand, and the receiver receives the signal, and that triggers this particular motor which is connected with your hand sanitizer. It can be an isopropyl alcohol, or it can be other types of alcohol of desired concentration, and accordingly whenever your hand is there, it senses your hand, and that switches on the particular motor, and the motor is now pumping the hand sanitizer straight away to your hand. And after, when you are removing your hand, it again stops the particular motor, and accordingly your hand sanitizer will stop. So this was prepared in my home. I was just willing to show this particular thing. It could also be you can say to manufacture, or it can also be designed in various other ways. Some of these are well available in the markets also. You would have seen hand sanitizing systems looking like this or looking like this. So in both of these particular systems, it works on the same phenomena of using these IR based sensors, or you can use the ultrasonic based sensors also, but mostly in the market it is mostly IR based sensors, because these are actually pretty cheap, and fabricating these things are pretty easy. Now let us move on to the next slide, and then let me explain a little bit about how these IR sensors basically works. Now these IR based sensors, as I have already said, that you have two different LEDs. One is said to be the light emitting. These are actually the light emitting diodes. So this can be connected with either a relay board or without a relay board. So we'll come to this relay thing later, and without this relay thing later, but let us now understand how this particular sensor works, and what are the various components which are available in this particular sensor, which helps this particular system to actually work it. So if you could follow this particular figure over here, this is nothing but this is a very simple circuit diagram. So this particular IR sensors or infrared sensors actually consists of two main components. One is the IR LED and the other is a photodiode. This is basically an IR LED, and the black one, which we say is to be the receiver, is nothing but it is an photodiode. Photodiode. Now, this IR LED is like a normal LED, which is going to emit light in the IR range spectrum, and therefore it is not visible to human eyes. The photodiode, which is also called as a light dependent resistor, this particular thing is also said to be the light dependent resistor. It is actually having a very high resistance in the absence of light, and the resistance of this particular photoelectrode drops whenever light falls on it. So whenever this particular photodiode is receiving some sort of IR light, its resistance decreases dramatically, and it activates the entire circuits inside it. So that is the resistance of this photodiode. Basically depends on the intensity of the light falling on it, and this photodiode is again it is a semiconductor which has a PN junction and is operated in a reverse bias. That is, it starts conducting a current in its reverse direction whenever light falls on it. Okay, now let us see how it works with the help of this particular circuit diagram. So in the circuit diagram, you basically have a 5-volt DC supply, which is said to be VCC plus 5 volts. So this is the supply, and you have the ground connection over here, which is said to be the ground, GND ground. Now this 5-volt power is actually needed for this LM358. This is nothing but it is LM358 OP AMP. So these are nothing but these are low power dual operational amplified integrated circuit, which is originally introduced by National Semiconductor, and it is used to is basically used in the detection circuits. Now this particular 5-volt power is actually needed for this particular LM358 OP AMP and the photodiodes and the IR LED. So you have this IR LED over here, which is nothing but this particular LED, and then you have the photodiode over here, which is the receiver, which you say is to be the receiver in a very precise language. So this is nothing but this is this particular photodiode, and you have a couple of resistors over here, and you also have a potentiometer over here, which is 10 kilo ohm potentiometer. And this LED is nothing but it is a normal LED, which will actually signify whether your circuit is complete or not. And this particular LM358 OMP will actually help you in giving signals in its digital format, either 1 or 0. So when this particular system is powered on, the IR LED emits light in the infrared spectrum, and whenever it falls on this particular photodiode, the resistance of this particular photodiode drops, and accordingly the voltage also drops. Okay, in this is given to the non-inverting terminal of this OP-AMP over here. You could see that there is one 10 kilo ohm potentiometer which is used in the output of this potentiometer, and the output of this potentiometer is given to the inverting terminal of the OP-AMP over here. This potentiometer is basically used as a reference. Why it is? Let me give you an example. For example, if you keep this particular potentiometer at 4 kilo ohms, and as you could see that the voltage is there, and that will lead to some value. Now this supply voltage with 5 volts in combination with this 4 kilo ohm will give some voltage, and that will go to this pin number 2. Okay. Now when this light will fall on this particular photodiode, the resistance, as I have said, the resistance will be dropping. Okay, and therefore the voltage will be varying. Now if the measured voltage from this particular process, this measured voltage is below this potentiometric voltage, which is over here, then what happens, the output will be low. That means from this particular section the output will be very low. That means it can be considered to be zero. And if the measured voltage, on the other hand, if it is above this potentiometric voltage, the output will be high, and that means it will give a signal as 1. So that means it will be converted into a digital signal, either 0 or 1. Okay. So it will give a digital output, that is 1 or 0, and the LED will glow if there is any output. That means if you are getting a signal, that means 1, this LED will glow, and if the output is 0, this LED will not glow. It works something like this, which I will be showing you after some time. So before this particular LED, there is another resistor, which is 330 ohms resistor, which is basically used to protect this particular LED, because we know this LED basically works with 3 volts power, as we are giving 5 volts over here, so that may damage this particular LED. So you have a resistance over here. So that is the entire circuit diagram of this particular IR based sensor. What are the components which are available in this IR based sensor? Now these IR based sensors, you could see in front of you. You also have it is there in front of you. Now, as I have said, you have this particular this photodiode, and this is the IR transmitter, and this is the potentiometer, which you can actually manipulate. And then you have a series of resistors over here. These are the resistors, and the LM358 OP AMP is nothing but this is the black one over here. Now when this circuit diagram is complete, let me just show you how this thing works. When the circuit diagram is complete, and if you are bringing your hand in front of this particular thing, you could see that whenever it is nearby its dedicated range, it is now, whenever this light is getting on, that means the photodiode is able to now trace the reflected IR light, which is actually being transmitted by this particular LED light. Now as you are bringing in front of it, now the system gets switched on, and when the system gets switched on, that will trigger some kind of action with the motor, so that your motor gets started, and your hand sanitizer liquid gets dispensed. And whenever you are removing your hand and it is being passed through this particular potentiometric range, then what will happen, the light will be off. Again, when you bring your hand near, this light will be on, your hand sanitizer will be on. When you are removing it, the light will be off and your hand sanitizer will be off. So it works in this basic principle only. So all of the hand sanitizing systems available in the market are mostly IR based, and this is one of the cheapest bit. Now you can actually increase or decrease the distance of sensing your hand by using this potentiometer. So this potentiometer is nothing but this is a 3-terminal resistor with a sliding and rotating effect. Now if you are rotating this particular switch over here, you could manipulate the distance of the sensing. For example, say if you want your hand to be sensed at this particular distance, you have to adjust your potentiometer accordingly. But with this particular adjustment, your hand has to be at this particular range to switch on this particular circuit. You could see here this light is blinking on when I'm bringing my hand near to this particular sensor, and whenever I'm getting it back, it is getting switched off, on and off, on and off. So this is the way how this particular sensor basically works. Now I have already discussed what are the various components available with these IR sensors. Now this IR sensors actually now has to be connected with the pump system. Whenever this IR sensor is now giving a signal 1, 0 means the light will not flash, 1 means light will flash. That means now this device is sensing something. Now whenever this device is sensing something, then you have triggered some kind of an action where this pump has be activated. The pump can use some kind of a submersible pump, and if you have a submersible pump, you can straight away inside your hand sanitizing maybe a bottle, or it can be a storage container. It can be inside that, and whenever this sensing will be working, this pump will be activated, and using a pipe you can dispense that particular hand sanitizer out. Now in order to connect this particular motor, you need to have two different setups. One setup is either you can go with something which is said to be a relay board, RELAY relay, or you can use another kind of an PNP based transistor, which is said to be TP32C based transistors. So you can either use a relay or a TIP32 PNP power transistor. So both could be used. If you are using a PNP TP32C transistor, then you need to use 1 kilo resistor over here that has to be connected with this particular terminal. So basically it is having three different terminals. One is said to be the collector, which is said to be the C. Then you have something which is said to be the emitter, which is E. This is E, this is C, and B is said to be the base. Now, this particular sensor, as I have showed in front of you, it will be having three different signals. One will be having the VCC, which is the power, one is the ground, and the another is the out. Now, this particular thing, which is said to be the power, that power or the VCC has to pass through this 1 kilo ohm resistor, and it has to go and connect with the B of this particular transistor. And this black one is nothing but it is negative of this particular motor. So you can use an USB cable. The red one will signify the positive and the black one will signify the negative. The positive one will go and it will connect with the out of this particular not the out, it is basically a VCC part of this particular sensor here, and accordingly another part will go and connect with the E part, which is the emitter. And then from the DC pump also, the negative terminal, one part will be going and attaching with the C here, and the other will come in and touch with the DC pump. So accordingly this particular circuit will be complete. For example, this particular setup is basically using a PNP this TP32C PNP transistor. As you can see in front of you, it is having three terminals: the emitter, base, and the collector one, and it is connected appropriately using with this particular sensor. And there is another resistor, as you could see here. This is 1 kilo ohm resistor is there, and when this circuit is complete, you have another motor connected with it. So whenever you have some obstacle in front of you, like when this obstacle is in front of you, this will trigger this particular motor to switch on, and this motor will be sucking the hand sanitizer from this bottle or whatever setup you are having, and that will be dispensed out. So in this way this particular sensor will be working. On the other hand, if you use a relay board, this relay board is also a type of an electrically operated switch, which basically uses an electromagnetic coil inside it. So whenever you have any signal coming into this particular relay board, what will happen that it will trigger some action to the pump. Basically, if I say this particular setup, this will trigger and signal to the motor, and the motor will be switched on, and accordingly it can be dispensed off. Now this if you have a relay board like this instead of this TP32 transistor, the advantage is that if you are not using this small submersible pump, if you are planning to use a pump which is of a bit higher capacity, as this particular video you could see here, the same thing was there was a relay board is there. Using this relay board, I was using a pump which was operated at 24 volts, and whenever it is detecting a hand in front of it, it is triggering some action, and this motor is now being activated, and whenever this motor is on, it takes the alcohol from this particular bottle and it dispenses out from this. So this was used a relay board, but if you are not having a relay board, you can use the this kind of setup, which is said to be submersible pumps, which basically works on 5 volts DC power. Let me give you a small video of one such setup which was developed in our university during this COVID period, and it was implemented in the university. Let me give you one demo. Here you could see there is one person who was just bringing his hand in front of this sensor, which is basically incorporated in this particular board. And whenever he or somebody is bringing this hand in front of this sensor, what happens, triggers some action into this particular circuit, and the motor gets switched on. And as long as his hand is there in front of the sensor, and you can say as long as this light is being absorbed by this photodiode or the receiver one, the motor keeps on working. And whenever the hand is removed, that means the photodiode is not receiving any signal. That means there is no obstacle. It gets switched off. So this is how this kind of devices can work. So this motor can either be dipped into an water based container from which it can take out water and it can dispense water, or if you have any alcohol based systems also, then also you can use this particular system. Now, this particular sensor, which is the ultrasonic based sensors, I would not like to go into depth of it. I just like to say that this ultrasonic sensor, as I've said, that it is out of our audible range of human. Our audible range is between 20 hertz and 20 kilohertz. This ultrasonic is actually inaudible to us, and these ultrasonic waves are basically used by bats for its movement, or fish. Some special kind of fishes are there that uses such kind of activities to move on. Dolphins also use such kind of ultrasonic waves for its movement. Nowadays there are various medical instruments are also available which uses ultrasonic power to operate various things. Now, as I've said, this also works with the same principle. The sound wave is being emitted from this particular transmitter, and whenever you have any obstacles, this can be your hand also. And from your hand, if some of the these waves are reflecting back as an echo, that is traced by this particular receiver, and that, if connected with an Arduino based sensor, it is now being sensed, and accordingly this Arduino will be triggering some kind of an action which will lead to the pump to actually start, and your water or your alcohol will be dispensed accordingly. Moving on. The previous two sections were mostly those sensor based devices. Now this particular section I would like to highlight a little bit about how this without sensor, how those systems are working. Most of you would have seen in the markets that whenever you are pressing this kind of an a system where you have an alcohol, or you can have soap in this dispensing column, and whenever you are pressing this particular pedal with your foot, what is happening, this particular section is now being pressed down, and as it is pressed down, whatever soap solution is there, it is being dispensed out of this particular setup. This is pretty easy actually. Moving on to the next particular slide. Here, this picture was also taken from our Tripura University campus, where we had implemented one such devices which was not using any sensor. The reason being, there are actually some limitations while using these IR based sensors. Now, the IR based sensors, only the problem is that even our sunlight is also having an infrared range. Light is also being emitted by the sunlight. So if you are making any hand sanitizing system made of IR, and if you are bringing in sunlight, then what will happen? It will actually the photodiode will be actually taking the ultraviolet, taking the infrared light which is available from the sunlight, and that will automatically trigger on the circuit inside it itself, and the hand sanitizer or the liquid will be simply keeping on coming out, and you will not be able to control it. So these IR based devices are only used inside your home, where there is no provision of direct sunlight falling on top of these particular sensors. Whereas if you're using the ultrasonic based sensors, as it is not working on this light, so until and unless it is not receiving any form of ultrasonic signals, it will be working fine. So these are some of the limitations of using this IR based sensors. Though it is cheap, but you have to keep into mind that it can't be used outside where direct sunlight is there. Otherwise, if you need to prepare some devices or hand sanitizing system where it has to be used in sunlight or maybe outside your home, then you have to go for this ultrasonic based sensors. That means with ultrasonic, you have to purchase the Arduino, and then you have to code, and then it has to be used. Similarly, for our Tripura University campus near the main gate, what we had done is that instead of using these IR or the ultrasonic based sensors, what we have used is the normal pedal based switches. What we had done was nothing, but we had a storage container which was having water, and there's one pump which was connected to the storage container, and this pump was operated by using a 24-volt DC adapter, and this connection was made via this particular pedal. So whenever you are pressing this particular pedal, that completes the entire circuit, the pump gets activated and the water gets dispensed from this particular section. You could see here, whenever this somebody is coming and pressing this particular pedal section, that activates the entire circuit. The pump is now able to take the water from its storage container, and it is dispensing through this particular setup. So this was also used in our particular campus. So this can also be used for touchless sense. So this is not entirely touchless, but you can use your foot for operating this particular system. Let me now go on to the next slide. Yeah. So as I have said, this particular system was also implemented throughout our campus in Tripura University. This was a picture from our Tripura University guest house, where this kind of devices were kept. This was nothing but this was the pedal-based switch, which was switch on, pressing it. This liquid is coming out. It can be any kind of a soap solution, and it will be dispensed into your hand. And after cleaning your hand, you can either use your pedal based system, or you could see there that sensors are actually coming out over here. This was nothing but this was the IR based sensors, where you had the transmitter over here and the receiver over here. So whenever your hand was near to this particular sensor in its detectable range, so your light from this IR sensor was coming, and you're getting reflected from this particular hand and getting back to this photodiode, and the photodiode is activating itself, and accordingly there was one small motor in the bucket which was running, and you could see this water is being dispensed, so you don't have to touch anything. So this way it was actually done. Moving on to the next slide. Here also you could see that this kind of systems was also utilized in the main administrative building of our university, as well as the entry and the exit gates of our university. And this system worked quite good during our that last year when we had this typical pandemic time of us. So these are all the type of sensor based system. One such system which I was just planning to show it for today was actually well appreciated by our honorable Minister of MHRD, Dr. Ramesh Pokhriyalji. He had well appreciated one of our innovations over here. In this particular innovation, what we had done, we had prepared a touchless hand sanitizing system, and after you have cleaned your hand, whatever the dirty water was going out of your hand was not straightly disposed to the environment. Rather, it was stored in one container, and from this container there was one water purification setup was established, which had led to the recovery of lot of water, and this had actually helped us in conserving a lot of water instead of simply discarding the water straight away to the environment. So this was also employed in the Tripura University administrative building, and a lot of water was saved using this particular technology. Let me play this particular video.
As you can see here, here you have got a stand by which you can dispense your soap or your hand sanitizer by simply pressing the pedal. You have a very simple clip here which works as a screen. You have seen this clip in your offices, or maybe somebody might have this in your home. And once you press it, it gives some tension here. It gets stressed, and when it gets stressed, you get the soap coming out from this dispenser. And then because of the spring action, it goes back to its position, so that you can again keep on pressing, and as long as you keep on pressing it and losing it, it works to take the soap solution out. So after that, what I have done is I've made a electrically operated system by which if you could press the button, you have the water coming out from the system. So you don't have to touch anything. You don't have to touch the taps, or you don't have to touch the sanitizing system. So the system gets the clean water for cleaning from this tank, and from this tank we get the clean water. And after you cleaning your hands, the dark solution goes and gets stored in this system. And from this system, you could see that a lot of water along with the surfactant goes out to the environment. What I have done is I tried to recover some of the water out of this wastewater, so that it could could recirculate it back to the system, and so that we could save water. So once you have the water here, you just have to you could see that it is coming from this sink to this device, and you have this pipe. From this pipe, it goes that's connected to this pump, and from this pump you have a couple of water treatment facilities. We have pressure gauges by which you could see that what is the operating pressure, and we have optimized it in such a way that the water plant works very safely. And then what happens is that the water gets treated in setup 1 and 2, and from 1 and 2, the wastewater goes out as a reject, and the clean water comes to the UV system, so that if any microorganisms present gets treated here. Basically, when you have a very good membrane-based system, there are very less chances that membranes will work very good. So as I was saying that if you have a very good membrane-based system, there are more chances that the microorganisms will not be coming up. Anyway, when you have the soap solution here, the microorganisms gets ruptured, and anyway they are already in its killed and ruptured form here. But even if some microorganisms are
okay, this system was developed by us, and here we could actually recover around 30% of the water which would have actually got wasted if we had simply rejected it to the environment. So around 30% of the water we were able to recover it back to our system, and that was again used for subsequent hand washing. So this particular technology was actually a part of research work which was done by one of my master's student, which was basically a part of this gray water recovery techniques. And this gray water recovery technique was actually utilized in this particular hand washing system, and accordingly it was materialized. That system was making use of two different technologies. One was using an RO membrane, and another was using an ultrafiltration membrane, and it was followed by an UV treatment, which was utilized to deactivate if there were any microorganisms present, and then the water was made safe for its subsequent hand washing. So this was a technology which was straight away taken from our lab and implemented in our university for wastewater recovery, and accordingly it got a lot of praise. Now, coming to the concluding remark of today's talk, that why this particular hand sanitizing systems are still very important, because we all know that this pandemic is still not over for all of us, and we still have to maintain social distancing and clean our hands from time to time. And as we know that this particular microorganisms, now it is COVID, but apart from COVID, we have a lot of other microorganisms which can harm us in our day-to-day activity. So it is not only for COVID that one must have such kind of a hand sanitizing systems with them, but also for the future when this COVID will not be present, or when we all get vaccinated. Maybe slowly by slowly this COVID thing will go out, but these microorganisms are going to stay for a long time with us. And so you must have some kind of a devices, and if you are ready to prepare such devices, these devices are pretty available in the markets also nowadays, but you have to pay a hefty price to purchase those hand sanitizing systems. Instead, if you could make such kind of an hand sanitizing system either Arduino based or without Arduino based, I'm sure there are pretty good number of videos already available in the social media also, as well as the YouTube also. You'll get a lot of videos which will help you to actually construct such kind of a hand sanitizing system. This particular device was initially it used to be construct in the laboratory itself. This circuit was prepared by connecting those photodiodes and transistors and the potentiometer as per the circuit diagram which I had shown. But nowadays this kind of devices are well available in the market, either in the Flipkart or Amazon, and you can get it at a very cheap price of around 300 or 350 rupees. So you don't have to make a circuit and do all those stuff. These are straight away plug and play kind of a devices already available. So instead of paying 1,500 and purchasing those hand sanitizing system, you can make use of this particular method, and you can prepare your hand sanitizer stay away in your home. And hopefully that will help you a lot in tackling these microorganisms, COVID for the time being. Okay, so with this particular remark, I would like to stop today's presentation. I thank you all for being patient, and thank you all for listening to me. If you have any questions from your side, I would be glad to hear and answer. Thank you so much. Over to you, Mandakini.
Thank you, sir, for
Yeah.
your presentation, and thank you for giving us your valuable time. No questions are here in the chat box
Okay.
till now,
Mhm.
so we can close this session here. Thank
Okay.
you, everyone.
Thank you so much. Thank you so much.